All right, last example for me today of chain rule, and our function, this last example, is y is equal to 1 over 3x plus 2. So again, like the last example, the first thing I'm going to do is rewrite this function so that it is an exponential function. And if 3x plus 2 is in the denominator of a fraction, I can rewrite this function like this. -1 power. Okay, now that's going to let me figure out what's my inner function and what is my outer function. My outer function, once again, is a power. It is the -1/2 power. So I'm going to call this x to the negative, not -1/2, excuse me, -1. And my inner function is the 3x plus 2. Okay. So that's the decomposition of functions, and like I said, you will be doing that in the homework where you're splitting apart the inner and the outer functions so that you can then apply the chain rule. So, speaking of, let's do that now. So if I want to find the derivative of this function out of there now y is known as d over dx, then I want to first find the derivative of the outer function, and my outer function is x to the -1. So I'm going to basically apply the chain rule to this. So I'm going to have -1 times 3x plus 2. I subtract 1 from -1. That's going to give me -2. So that's this part of chain rule. I found the derivative of the outer part of the function. And then this part of chain rule, I'm going to find the derivative of the inner part. And the inner part is 3x plus 2. This is easy peasy for us to find the derivative of. At this point, it's just, let me hear you say it. You got it, 3. So that's my derivative in raw form. I'm going to clean this up a little bit because I've got a negative exponent and I've got some numbers I can pull together. So my derivative cleaned up is going to be -1 times 3 is -3 over this negative exponent. It tells me to move this to the denominator. 3x plus 2, and it's a -2, so that's going to be squared. And there you have it.